Now we see another recursion tree, recurrence relation, and we solve it using recursion tree. Okay, the recurrence relation is Tn equal to 3t n by 4 plus theta n square. So like in the merge sort, it was like, just to compare and contrast, Tn equal to two subproblems, each of size n by 2 every time the array is being divided by 2, plus theta of n for the merge part. So here this is Tn equal to 3Tn by 2. So there are three subproblems. So every time a tree will be divided into three parts, because in here for the merge sort, every time the tree was divided in two parts, because every problem has two subproblems. And n by 4 is the the input size every time the input is being divided by in four parts. And this is the combined part, okay, theta of n squared. If we compare and contrast, so this one, as I said, we can ignore the floor and ceiling kind of operators, so we can write it simply as 3t n by 4 plus c times n squared. C is the constant value when we do the actual calculation. As I said, we have to replace the theta notation with a constant. Okay, when we do asymptotic analysis, so this is actually asymptotic to non-asymptotic. Okay, if from Cn square, if we make asymptotic analysis, we'll say theta n square. From theta n square, if we want to do actual cost, we'll say c times n square. C is a constant. You see that stage 1 is here. When we say that Cn square is the cost, we write it in the root, and there are three subproblems, each of size Tn by 4. Okay, so you can see that here three subproblems, each of size Tn by 4. Now at the next level, what we do, this n by 4, T of n by 4, how we solve it? We put n by 4 in this equation and get 3t n by 4 divided by 4. So it's n divided by 16, okay, and n squared divided by 16. Okay, so n squared divided by 16, and so we replace them here. So it's Cn squared divided by 16 for every for this recurrence itself will become a subtree where the cost of this part will be Cn squared by 16, the constant part, and three subproblems, each of size Tn by 16. Okay, so in that way we continue moving on, and so then we come to the third stage of the tree. We don't need to show all the stages. So here we show the root, and then the constants. Here for Tn by 16 we change it to C n square by 256. Okay, so here now and then there'll be this will be subproblems n by 64 every time you divide by 4 and 4, and that way. So they will have. So now we need to calculate the height of the tree. Okay, how we calculate the height of the tree? So finally we know that if we keep dividing the problem at one stage, it will be single element array. So we say, okay, assume the every time it's divided by n by 4 to the power I. Okay, we can even so in that way n equal to at the n by 4 to the power I equal to 1 at the ith level. Okay, so what we do, we say n equal to then 4 to the power I. If we take log n to the base 4 to both sides, then what will happen? So this will be log n to the base 4, and this will be I. So I is the height of the tree. Here I write h, I and h are same. So log n to the base 4. Now let me wipe it out and then calculate the cost at each level. At this level the cost is Cn square. At this level the cost is 3 Cn square, 3 by 16 Cn square. What about at this level? There are 3 3s are 9 nodes. Okay, so this is 256. So I can write it like 9 by 256. Is it 9 by 256? Yes, Cn squared 9 times. So 9 by 256 Cn square, which is again equal to 3 by 16 whole square Cn square. Okay, so in that way at every level you will see at the lowest level, if you remember, we said that if there are n number of leaf nodes, so that will be, you know, theta of n cost at the leaf level, and this is a series summation. Okay, so how the series looks, it looks like Cn square plus 3 by 16 Cn square plus 3 by 16 whole square Cn square. So after some time we can just say that this pattern will follow. Okay, so if we take Cn square outside, it is like a 1 plus 3 by 16 plus 3 by 16 whole square plus 3 by 16 whole cube. In that way it will go on. Okay, so whatever be the value, you can see this is a decreasing series. Okay, it's a decreasing series, so this is more than 1, it is 1 plus something, but this is definitely, because the decreasing series is it will be, this part will be less than 1, how big this is. So this is actually together 1 plus this will be less than 2. Okay, so we can say that this part is bounded by 2Cn square. Okay, so this is the way we approximate the infinite series, and then finally the cost is, so number of leaf nodes, we said theta of this, not in number of leaf node. The leaf node in this tree is a to the power h. Okay, a to the power h means a height is the, a is the you know, number of total number of leaves is how many times is being divided. So 3 times is being divided. A to the power log n to the base 4 number of leaf. So this is like n to the power log a. Okay, n to the power log a to the base 4, you can say. So it's actually n to the power log a, and then finally a is what, 3 here, right? Yes. So a is the number, how many times being divided. So n to the power log 3 to the base 4, and this cost is Cn square. So plus 2Cn square. So whatever this is, this Cn square is a larger term, so this will become theta of n square. Okay, so this part up to the leaf level is Cn square as we calculated here, and the leaf level is a to the power h. A is the, how many times the tree is being divided. For binary tree is 2 to the power h, if you remember, for this a to the power h. So like this has 3 children, so a equal to 3. Okay, so every time a equal to 3. So like this is a actually. So this is a to the power h, the number of leaf node at this level. Previous one we did is a binary tree, but here this a to the power log n to the base 4. So by the base change of logarithmic formula, this becomes n to the power log a to the base 4, which is a equal to 3. So n to the power log 3 to the base 4, and n to the power log 3 to the base 4 is less than n square. So the final, the dominating term is Cn square, which when represented in asymptotic format will be theta of n square. Okay, so now we can say that Tn equal to 3Tn of theta n square. This is actually big theta of n square. So now we see another example of solving recurrence using recursion tree after the merge sort one.